my name is Steve Holt. I'm one of the Alliance Program Managers. We're here for the Spring 2010 Partner Night. Partner Night is a really important part of the TSC. It's an opportunity for 31 partners, that's a record by the way, to showcase their IP, their boards, their design services. This is a really important function. It allows our FAEs to get face time with these really important partners and understand the value that they bring to the sales process. Thank you and enjoy Partner Night.
Hi, we're from Brilliant Telecommunications. We're a startup company. Started off in 2004, and the focus of this company is in network timing and synchronization. We provide timing solutions for packet-based networks, mostly the IP backhaul network, as well as the femtocells and picocells that are currently very popular in the mobile industry. Now, what's happening in the IP backhaul space is that there's a growing need for bandwidth at the end user devices like cell phones, and operators are enhancing their networks, replacing T1 and E1 or TDM based networks with packet based networks. So there's a need for synchronization using packet based techniques, and Brilliant provides the packet based timing solutions using NTP and PTP protocols. All our products are based on Xilinx FPGAs, and as you can see here on this slide, we make a number of products, server products, client products, as well as modules and chip-based IP, all using Xilinx FPGAs. And these devices basically include the entire protocol stack as well as synchronization algorithm to control oscillators. Today we're working with a number of operators. Our solutions are deployed in live networks, and this is a solution that provides both frequency and phase synchronization for a number of mobile wireless technologies. Thank you.
Hi, I'm Dan Brodsky here from Wind River Systems. I'm based in Boulder, Colorado, just a few miles up the road. And we're showing tonight VxWorks, real-time operating system, and also Wind River Linux, another operating system that can run on your target board. We're also showing Workbench, which are the host-based development tools that the application developers use to develop their application. So tonight we're showing VxWorks 6.8 running on the Xilinx ML507 board. It's PowerPC Core, and the operating system is running along, doing its thing. And on the host side, we have Workbench running, where the application developer will write their code, compile it, and debug it over an Ethernet connection to the target. For more information about Wind River, our services and products, visit our website at www.windriver.com. That's WINDRIVER. Thank you.
Hello, my name is Adam Smith, VP with Alpha Data. We are a hardware manufacturing company, and we primarily deal with high-end small form factor boards. We're based in Edinburgh, Scotland, have an office in San Jose, California, and we'll soon be opening an office in Denver, Colorado this year. So what we're showing here tonight is a few of our products. These are PMC and XMC boards. So we have a modular solution that's used in embedded computing applications. Our primary customers are military, aerospace, a lot of big defense contractors. And what we offer is a modular solution. So you can take our base FPGA boards, and we have a whole series of different I/O daughter boards similar to an FMC idea. You can do analog inputs and outputs, high-speed serial connectivity, high-density digital I/O for many, many different applications. One unique thing about our boards, we have a bridge that interfaces back to the host, so PCI Express and PCI Bridge, which allows you to use The majority of the target FPGA all for the user design, so kind of provides a blank slate for the user to do whatever they want with this. Many, many different applications that it can go into. What I'm demoing here tonight, there's a camera link that's set up here. So data's coming in the camera, interfacing to a Vertex 5 FPGA, capturing the frames from the camera, doing a simple edge detection on that, and piping the data back to the host over PCI Express. So kind of just showing the reference designs and examples that we provide along with our hardware. Basically allowing customers to use our boards directly out of the box, providing many of the basic building blocks that they'll need for their design. So allows customers to customize what we've worked on, and just a great start to be able to provide their own design on our hardware. For more information, visit alphadata.com, or you can also send me an email, my full name, adam.smith@alphadata.com. Thank you very much for your time.
Hi everyone, my name is Farhad Shafaya. I work with Xilinx Technologies, and we have a couple of demos set up here. This one here is running a 50 gigabits per second interlaken demo with 8 lanes running at 6.25 each, 6.25 gigabits per second each. 6 of the lanes are loop back internally inside the FPGA, and 2 of them are loop back externally with the SMA cables. It kind of shows the IP's DSKU capability in that there's 6 lanes loop back internally, but 2 of them come out to the SMA cables, and the IP is capable of DSKUing all that difference between the different lanes. We have a chip scope program running here. There's a simple packet generator and a packet monitor inside the FPGA, and the chip scope is used to monitor the packets sent and received. So I don't know if you can see it in the video or not, but there's a packet counter here that's just counting up number of bytes and number of packets sent and received, and there's no errors or anything like that. That's this demo. Over here on this demo, it's a Vertex 6. We're running 100 gigabits per second Ethernet MAC PCS IP. Everything in here is loop back internally. Technically, the SerDes are supposed to be 10 gigabits per second, so we don't have any SMA cables for this. It's a LXT FPGA, but it's 100 gigabits per second data path that's running inside the FPGA. We have a similar type of a chip scope set up here where there's a packet generator and a packet monitor sending data, and traffic is monitored over there. Again, the byte counts and packet counts are going up, and there's really no errors or anything like that. Yeah, I guess Xilinx Technologies, stepping back for a second, we provide IP. Our major product lines that are specific, actually we're demoing here, is the Interlaken and Ethernet MAC PCS. Our Interlaken IP can carry bandwidth anywhere from 10 gigabits per second up to 125 gigabits per second in the Vertex 5, 150 gigabits per second in the Vertex 6. And on our Ethernet side, we have 10 gig MAC PCS, 40 gig MAC PCS, 100 gig MAC PCS. The IP from our perspective is pretty complete. It's used by Cisco all over the place. Huawei uses it quite a bit. Ericsson uses it, just to name a few of the tier ones. The IP also goes in ASSP, so it's in Dune, accelerated, easy chip IP as well. And that's very good from our perspective, because anybody using those devices will then put a Xilinx FPGA beside it and uses our IP on both ends. So whenever ASMC comes out, we get an FPGA sale that goes along with it, which works great for both us and Xilinx. So that kind of wraps up the demo here and our products. If anybody wants any more information, please go to www.sarance.com, SARANCE.com, and look there, or send an email to info@sarance.com, and we'd be glad to answer your questions. Thank you.